It looks more like the probability plot that you've seen for one of the d orbitals. It's actually dz. The complete name of dz square is dz square, 3z square minus r square. So if you think of 3 cos square theta, right, or 3 cos square theta minus 1. So 1 means it's x square plus y square plus z square, everything. That's r square. And if I think of only cos, then it's only z. So 3z square minus r square is the complete name for that. But remember, these are never ever called as shapes. These are the probability distributions, right? And you know, a lot of chemists also make this mistake when they actually think of them as shapes. These are not shapes, right? The particle is on the sphere. Well, if I don't go to the hydrogen atom now, I know that the particle is on the sphere. It's only the probability at a particular angle that I am plotting it. It's not the shape. Okay. Now, I know that the probability of seeing the particle somewhere on the sphere is 1. So I have to worry about integrating this. Integral of psi star psi d tau. D tau is something I use for the whatever the volume element is. In one dimension it becomes dx. In 2 dimension, for example, Cartesian coordinates is dx dy. Okay. Now this is something that we'll need to define over here. And how do I do that? Think of this sphere again with my x, y, z coordinates, and I have a come straight. My eyes are bad. It's straight line. Okay. And so the sphere is of radius r. Let me take a small cross section of the sphere. So anyway, before that, I know that this fellow is r sine theta, right? So let me take a small cross section. Which will look like some kind of an arc. So this part, I need to then define what exactly is this part. This part is the one that is moving around phi, d phi. Okay. This is the one that is coming down from the z to z axis to xy plane. So that's kind of a d theta. Right? But it's at a distance of r sine theta. So this part, the small arc, is going to be the angle subtended over here, right? The small angle subtended over here, d theta, at a distance r. Right? So which makes it sine theta of d theta. Okay. So now, if I were to integrate, I know that my theta varies between 0 and pi, and phi varies from 0 to 2 pi. So then I have to write my integration 0 to 2 pi, 0 to pi, psi star psi, sin theta, d theta, then d phi. So that's like, this will be integrated first. Okay. Okay. So if you have to use this integration, use it. Now, it's the time only 46. Yeah, we have another 2 lectures, and I'll do the hydrogen atom in the next lecture, and one approximate method so that you can go beyond the hydrogen atom. At least I'll introduce you to one of them. Now I can stop this here.